Welcome back. We shall see how to create mesh using Ansys workbench for this wind turbine model. Let us close design modeler and double click Ansys workbench mesh. Now the models are imported into Ansys workbench meshing part. We can see two geometries, outer domain as well as rotor domain here. Now before starting the mesh parameters, we shall specify the region names here. So choose face option here in this selection menu. Click the inlet face of the outer domain and choose create named selection. Type inlet, click OK, and then choose named selection. Select the geometry in the outlet, click apply and rename it as outlet. Right click, insert named selection, use the other four sides, select apply and rename it as wall region. Now we can hide these faces, inlet, outlet and wall. Hide faces, hide the rotor domain, hide body. Now we have got the interface region and the support structure. Now we are working only on the outer domain. The rotor domain is hidden here. So right click, insert named selection, select the interface region, that is the three faces, and rename it as outer interface. Now we shall hide this outer interface. Now let us select the support frame. Right click, insert named selection, select the geometry. Here choose the box type selection. So here select all the faces in the support frame. Make sure to hide all other faces. Then you can select the support frame separately. Click apply. Because it has got 28 faces, you cannot pick one by one manually. Support frame. Now we shall hide this outer domain, hide body, and select the inner domain, show body. Now we shall specify the names for the rotating domain. Right click, insert named selection, select the geometry, change the mode to single select, click apply, rename it as inner interface. Okay, now hide this. We are left with the turbine blade. Now right click named selections, go to named selection, select the geometry using box select mode, click apply and rename it to turbine. Now we have specified the names for all the region. Now we can show all the bodies. Next we shall specify the mesh parameters. In the mesh we can choose the physics preference as CFD, solver preference as CFX. Let the element order be linear. Element size, let us keep, by default it is showing 13 meter, let us keep around 5 meter. Here you can see the element size using this crosshair symbol size. Roughly the size will be the diameter of this crosshair. If it is 2 meter, it will be too small. If it is 10 meter, it will be too big. So let us choose around 5 meters. This is the element size for the global mesh parameter setting. Now let us insert and specify the face size for different regions. Right click mesh, go to insert and then sizing. Here use named selection and specify the regions where we wanted mesh size. First we shall choose the turbine rotor and specify the element size as 0.5 meter because rotor needs fine mesh. In the outer region the mesh can be coarse, but near the rotor blades it should be fine. Let it be 0.5 meter. Again right click mesh, insert sizing, select named selection, choose rotor domain interface, outer interface, let it be 1 meter, select named selection. Similarly repeat it for other main interface regions. Inner interface 1 meter, this is outer interface, this is inner interface, and let us select the mesh size for support frame because it has got many faces. Now let us add boundary layer elements around the blade surface. For that we shall choose inflation option. click inflation in the insert menu and select the region where you need to specify the inflation. Select turbine. Here you have to select the body. You can go to geometry selection and select the rotor domain. Hide this outer domain. Go to inflation. Select the body. Click apply. In the boundary scoping method boundary, you choose turbine. Now let us specify the inflation option. We shall specify first layer thickness. Let the first layer be around 0.075 7.5 into 10 power minus 4 meter. Let the maximum layers be 4 and growth rate let us increase it to 2.5. Now we have specified all the mesh parameters. Right click mesh and then click generate mesh. Now the mesh is done. Let us show all bodies and click mesh here. We shall choose cut section plane and then see the mesh near the turbine region. Choose section plane and draw a line near the mid region. We can see the inner region. Click show whole elements option so that you can see the elements. You can see the inflation region near the turbine blade. So now the mesh is ready. We shall go to CFX preprocessor and specify the boundary condition for solving.